to remind you, I purposely put all these problems up here cold. I just said, give me the whole section. It's been a few days since I selected problems from your homework. I didn't want you to see the canned, look, let me show you this answer that it took me 20 minutes to work out, and now you're expected to figure it out in 2 minutes just by staring at it, right? I want you to see the process as we think through these. So I recognize 256 is 16 squared. So x cubed plus 16 squared minus 16x squared plus 16x, but they have this in parentheses. Well, these three all have a 16 as a common factor, but this doesn't. These all have x as a common factor. But factoring by grouping is kind of odd because these don't have any common factors. So let's see here. If I distribute this negative, minus and then minus, I could maybe bring this term over with that one, x cubed minus 16x squared plus 16 squared minus 16x. Factor in x squared out here, right? This is x times x times x, so x times x times x, x squared times 16. And here these have a 16 in common. That's 16 minus x. All right, 16 times 16 is 16 squared. 16 times x is 16x with negative there. Now this is not quite the same as that. Here x is positive, x is negative. So let me try rewriting this. X cubed minus 16x squared. Put the x term next, minus 16x plus 16 squared. Same thing here, factor the x squared. Now instead of factoring out a positive 16, let me factor out a negative 16. Negative 16 times x is negative 16x. Negative 16 times negative 16 is positive 256. X minus 16, x minus 16. So I get x minus 16 is my common factor, times this thing, x squared minus 16. But 16 isn't just any old number, 16 is a perfect square. This is not a perfect square, that's just plain x. Can't break that down any further. But here I have x squared minus 16, so that's minus 4 plus 4. And even though 4 is a perfect square, none of my first terms are perfect squares. So I just leave it there. X minus 16 times x minus 4 times x plus 4. All right. X times x times x, that's x cubed. There we go. Okay, making sure I have the correct degree. And we're good. That was kind of sneaky. All right, just a couple more problems. 45 plus v cubed minus 9v minus v squared. These terms are all over the place, right? V is my variable. It's the only variable here. So let's put this in order. V to the third power is my highest degree. Next highest is v squared. Next highest is plain v plus 45. Looks like factoring by grouping again. So v squared, v minus 5. To get positive v, I'm going to factor out a negative. And then to get positive 45, negative 9 times negative 5. V minus 5, v minus 5. Oh, they're doing it again. V squared minus 9, difference of squares. They really like those sneaky difference of square factors. Right? Recognizing perfect squares is a really useful skill. You want to memorize those perfect squares if you can. V minus 5, v plus 3. Come on. v minus 3. And very last problem here, y plus 6 squared plus 2x, y plus 6 plus x squared. My goodness. Well, let's introduce something new for the very last problem. Why not? You might find this technique useful in some of the other problems where I didn't use it, and that's substitution. We often use t substitution. Substitution is just saying, take some expression, however complicated you want it to be, and say that equals this variable. Right? Variables don't necessarily just stand for a single value. They could stand for a whole expression. Right? That's what formulas are all about. We're writing a formula here, a literal equation. T is equal to y plus 6. So here's y plus 6. That's the same as t. Y plus 6 was being squared. That means I have t squared. 2x times y plus 6. Well, y plus 6 is called t now. There we go. Now, I'm not going to put t in my final answer. They don't know anything about t. I made that up. But it helps me see in the problem, here's t squared. Here's x squared. T times t is t squared. X times x is x squared. Tx times tx. Sorry, t times x is tx. T times x is tx. So add those up. 1 plus 1 is 2. Tx plus tx is 2tx. So this is positive, so these are positive. And I'm all set. Except t was really y plus 6. Y plus 6 plus x. T is y plus 6 plus x. And sometimes once we get to this point, there actually will be like terms here that we can combine. I think we had another problem like that earlier. But y, 6, and x are 3 unlike terms. So let me shift this so I can actually see it. Here we go, y plus 6 plus x. Y plus 6 plus x. And once we have different variables like this, it's not really clear what the best order is for this trinomial. There's not really a good standard form for that, so I'll just leave it the way I worked it out as. There we go. So that's all 44 problems from this section. I did not assign all of those to you, don't worry. But I hope seeing me go through it, even if some of it was a little over your head, some of it was a little fast for you, to give you a sense of the techniques of how I identify how these work. So I'll leave it at that.